Okay, guys. So let's start the session. And in today's class, we are going to start the statistics, right? So how to measure and analyze, right? Now, so what is meant by statistics? Statistics means measuring plus analyzing the data. Whatever the data is there, first we have to measure the data. What is meant by measure? Measure means first we have to calculate the value. For example, let us take like this. If we are having a continuous variable, for continuous variables, we have to measure what is the average value, right? This is one of the example. And if you are coming with respect to some kind of discrete, like in this class, how many students are there? I mean, in terms of gender wise, how many males are there? How many females are there? That first, for example, we are having this much of females and males. Males are 70 students are there and females are 30 students are there. Assume this is called as measure. Okay, first this is called as measure. Measure means here, what is the measure you are going to do is count. You are just counting. So count comes under measure. Measure means just calculate. And once we count that one, later we are going to analyze. For example, in this class, total 70 boys and 30 girl students are there. What you are going to understand? What you are going to analyze? That is secondary. First, we are going to count that one. Count means which is nothing but measure, right? So here, statistics is first measure plus analyze is called as statistics. Within the statistics, we are having two different types of statistics are there. Okay, two different types of statistics. One is called as descriptive statistics and one is called as inferential statistics. Two different types of statistics are there. Before moving to that statistics, let us understand what is population. Now, population means entire data. If you are working on the entire data, then it is called as population data. Population means total amount of the data as per your interest. For example, you are measuring about the placements. Okay, you are measuring about the placement or you are analyzing about the placements of my previous batch. In the previous batch, we are having 150 students. If I get the entire data of all the 150 students and based on out of these 150 students, if 100 students has got placed, I'm going to say 100 out of 150. That is nothing but 67% of the data was placed. Okay, that is nothing but 67% of the students has been placed. Now, when I get the entire 100% of the data students only, then I can say like this. For example, I have received only with 120 students only. 120 students only have shared me their details. Whatever they have got the placements or not placement, only 120 students has shared the details. Out of these 120, 100 I have got the placed. Now, how I'm going to analyze this part is not the population data. This is not the entire data. If you're having the entire data only, it is called as population data. Population data means complete data. Is called as population data. If you're measuring part of the population data, then it is called as sample data. Okay, the second one is called as sample data. Sample means part of your population. For example, if you want to analyze the feedback of the students, if you take all the students only, then only it is called as population. If you take only part of the population, then it is considered as sample. If you're asking only 5 students or 6 students, how was the class, and you're confirming means, then it is sample data, not the population data. Population means entire data, sample means part of the population, some part of the population, right? And now, population where we are having it is a set of items or individuals. Example like with respect to the sales or with respect to pass or feedback, all this comes like in terms of voters, complete voters. And sample means a subset out of the voters in a particular constituency. We are having 3 lakh voters, assume. Out of 3 lakh voters, you are selecting 1000 voters on a part. Then it is considered as sample. Now, for example, let us take like this. Apple company is there. Apple present 14 series is going on. Apple iPhone 14 series. Now in Apple iPhone 14 Plus or 14 Pro or 14 Pro Max, whatever it is. Okay, model is secondary. Now some models are there. Now Apple is going to come with the Apple 15 series in the month of September. Every year in the month of September or October, they'll release the new product with respect to Apple. Now Apple 15 series is going to come in the month of September. Now what are the things they want to add in the Apple 15? Some modifications they have to do, or what type of modifications? That is based on the people's interest. If many of the people are interested towards the camera, means they'll focus on the camera part. If the many of the people are interested on the processor part, means they'll focus on the processor part. If the many of the people are interested on the night photography, means they'll focus on that. Which things the many of the people are interested? So for that, first what they have to do is, first they have to check the iPhone 14 reviews or feedback. Let us assume the iPhone 14. Okay, particular iPhone 14, I'm taking only one single one, iPhone 14. Now this iPhone 14 was sold across the world 1 million units. It is more than that only. Example. Let us take an example of 1 million units. 1 million units means 10 lakhs. Now we are having 1 million units, that is 10 lakhs. Miss, it has already sold. 10 lakh products already sold, completed. Now it wants to take the feedback. Now for getting the feedback, for example, if you are getting all the 10 lakh, complete 10 lakhs feedback, if you get from each and every person, if you get the feedback, then it is called as population data. Then it is called as population data. From 1 feedback to 9,99,999, if you get also, it is called as sample data only. If you get 9,99,999 also, it is called as sample data only, because one data is missing, right? Till 9,99,999 is considered as sample only for this case, right? So here we are having with respect to from minimum 1 to the maximum n-1 till n-1 is considered as sample. Now in the real life, let us consider as a real life example, the same example. Now assume that Apple 14 has sold total 1 lakh units, that is 10 lakh units it has sold. Now it has to get the feedback from all these 10 lakh customers. Now what they are going to use is SMS. They are going to send an SMS, or they are going to send an email, whatever the mail they have registered for the Apple ID, right? To that registered mail ID, they are going to send some kind of feedback or SMS, something like this. Or they're going to keep in the social media like Twitter or Facebook or Instagram, wherever it is possible, they keep one kind of advertisement. Please participate in the survey, something like this. Now, how many people out of 10 lakhs in real life they'll give the response for this one? Means 1 lakh only. Generally, 10% of the people only will respond. 90% of the people will not even respond. Right? Now, so here the based on these 10 lakh people has given the ratings, some ratings or some kind of feedback or everything. Now, out of these 1 lakh ratings, the average rating was given as 4.6. Now, this 4.6 is overall rating or only sample rating? Sample rating, but they will project this one as the overall rating with respect to, that is called as inferential statistics. We can project, but there is some calculation is there. Based on the calculation, we can estimate the population also. Means based on sample data, estimating population, estimating the population is nothing but your inferential statistics. This is called as inferential statistics. Based on the sample data, you are estimating the population data. Okay, based on the sample data, you are estimating the population data is called as inferential statistics. Okay, now what is meant by inferential? Inferential means conclusion, or generally inferential statistics means inferencing. You are going to have the inferences. Technical word called as inferences. What is meant by inferences? What you have understand from that. What you have understand is also called as conclusions. Both are same. What you have understand from the sample data, you are estimating. Okay, inferential statistics is nothing but your inferences. What you have inferenced. Okay, for example, in this class, I have checked like this, the males and females. Okay, male students are 70 students are there, female students are 30 students are there. Assume what you have inference. Your inferences you are going to write. Inferences is more number of boys are there compared to girls. You are going to write some statement. That line, whatever the line you are going to write, that line is called as inference. Generally, it is called as inference. That inferences, we are going to, that based on that, whatever the sample data inferences we are having, the statements, whatever the statements we are having on the sample data, based on that, we are estimating the population. That is the reason it is called as inferential statistics. Is that clear? So based on the sample, we are going to work. Now, in the real life, whether we work on the population or sample, means which one we are going to select, means we are going to work on the sample. In real life, everything we are going to work on the sample. Finally, if you consider this Apple also, Apple iPhone only, the same example, whatever we have taken. If Apple iPhone, whatever the ratings we are going to get, based on that, for example, I want all the 10 lakhs. All the 10 lakh ratings, then only I want to do the population analysis. Means now for getting all these 10 lakhs, we have to spend more money. Okay, in terms of advertising in the social media for continuously for 10 days or 15 days. Instead of 1 or 2 days, we have to spend for 10 days or 15 days. For 10-15 days, more money. It takes more money, right? In social media, we can't get the advertisements for free of cost. So it will take one. Second, some kind of lucky draw system we have to keep. So whoever has filled this particular feedback, whoever has participated in the survey, the Apple is going to take some kind of lucky draw system, and the person who wins, he'll get 3 nights and 2 days at Goa. Then more number of people will be interested to fill the form. Example, right? Next, for in terms of next time also it will take more time. So these are the 3 disadvantages we are having in order to collect the population data. So that is the reason we'll go with the sample. Every time we'll select the sample. Okay, why sample we are going to select means because it is a less time consumption and less costly when compared to the population data. It is less costly, and to be more precise, population is impossible. Sampling is the only option with us. To be more reality means this is the only option we are having. This is highly impossible. Not only here, everywhere it is highly impossible. So everything, whatever we are going to do in the real life is inferential statistics. Completely inferential statistics we have to do. For estimating, for calculation purpose different, estimation purpose different, right? Now, next we are having 4 different types of analytics. Analytics means analysis. 4 different types of analytics are there. So for understanding these 4 types of analytics, 1, 2, 3, 4, let me explain with a simple example so that this type of analytics will be easy for you to remember or to understand. Assume there is a patient. One patient is there. Patient means, what is meant by patient? He is having some kind of health problem. Okay. Now, whatever the patient is there, he has went to a hospital and he has met to a doctor. And there he is going to tell the first thing. What are the first thing he is going to do? Means he is going to explain to the doctor about his problem. He is going to describe the health problem. Whatever the problem he is having, he is going to describe the problem. First step, he is going to do this one. For example, he is going to say, sir, that I'm getting the cough from last 2 days, or some kind of feverish in the evening hours. Something he has described something like that. Now, what doctor will do? He will keep first initially the stethoscope, and he will check with respect to the heartbeat or abnormal or normal, everything. And later he will write some kind of scans. Okay. He'll do the diagnosis. So diagnosis he is going to perform. That is using the some kind of scans. Okay. Like for example, if you are saying some kind of feverish, he will ask us to take the malaria test. If you say some kind of COVID symptoms, he will ask us to take the COVID test. Something, whatever the related problem is there, related to that, whatever the tests are available, he will write that all the tests. And once based on the test report, once we get the test reports, and based on the test reports, he is going to predict what is the exact problem. Based on the report, he is going to predict the problem. He is going to predict the whatever the issue is there. What is the issue? Predict the issue. Or whatever the health problem, predict the health problem. He is going to predict the health problem. Once he predicts the health problem, what he is going to do? He is going to prescribe some medicines. Prescribe the medicines, and he will tell that if you take these medicines, automatically it will be set within 1 or 2 days or 3 days or 4 days, whatever the time. According to that, he will give the medicines. Now, the same to same, the first one, describing the problem, is called as, in analytics, it is called as descriptive analytics. It is called as descriptive analytics. Descriptive analytics means nothing but describing the data. Here, the health problem is nothing but data. Describing the data is called as descriptive analytics. Okay, just you have to describe whatever was happened in the past. Just you have to describe the past. Means whatever was completed. For example, sales are there. Sales of a company are there. Till January, whatever the sales was completed, that you have to describe on. You should not say that, sir, in the future, this will be improved like this will be happen like this, or if you do like this, it will be nice. If you work like this, it will be. No, don't say anything. Just whatever was happened, what happened, simply to say what happened already. What happened, okay? Whatever happened, just with respect to, you explain that one. It is called as descriptive analytics. The first one is called as descriptive analytics. Second one is called as, there should be some reason behind that. Whatever was happened earlier, there should be some reasons. For example, you have got a very good feedback. What is the reason? If you have got a worst feedback, what is the reason? If you have got a neutral feedback, what is the reason? For everything, one reason will be there. For anything, one reason will be there. So that reason, identifying the reason, how was happened, how was that happened, that one is called as diagnostic analytics. Diagnostic analytics. Identifying how that particular scenario was happened. Right? Next one is, based on that, you are going to predict the future, which is called as predictive analytics. based on which we are going to predict is called as predictive analytics. For getting that type of prediction, what we have to do is called as prescriptive analytics. Predictive analytics and prescriptive analytics. Let me explain with a simple example. Let us take a stock market. Okay, in the stock market, we are having the shares, right? Let us take, many of you may not be familiar with the stock market, or you may be familiar. So let me explain with a simple way. There is a company called as Infosys. Infosys, as everyone knows, Infi. Okay. Now Infosys share price. If you consider the Infosys share price on the day wise, on the x-axis you take the day wise, date, right? Or dates on the x-axis, date, right? And on the y-axis you have to take the share value. On the particular day, the share value is this one. On next day, the share value either dropped or increased something. Okay. On the third day, whatever the share value is there, every day, this is day 1, day 2, day 3, day 4, day 5, day 6, 7, 8, 9, 10, 11, 12, whatever the days are there. On the day first, that is, let us assume January 1st. Don't say it is holiday. Example, assume it is a working day. Okay. January 1st, whatever the Infosys share price is there, that value will be there, some value. That value, keep a dot based on that value, whatever the value you have got. Okay. On January 2nd, whatever the Infosys share price value. On January 3rd, on January 4th, on January 5th, on January 6th, on January 7th, January 8, 9, 10, 11, something you are having like this. Okay. Now just if you connect all these dots in a sequential order, if you connect the dots, then it is called as line plot. Line plot means connecting the dots in a line. That to sequential order. Whatever the order of the data is there, that order only you have to connect. Right? So connecting the order of the points is called as line plot. Right? Now, for example, I'm having a line plot in this way, or with respect to the data I'm having. Now in this data, what is the maximum value? This is the maximum value. What is the minimum value? This is the minimum value. Right? This is the maximum value. This is the minimum value. This is the average value. Somewhere average value will be there. This maximum value, minimum value, average value, all these are called as descriptive analytics. You are just describing the data. The data means the Infosys share price having the maximum, minimum, this much of values. That is called as descriptive analytics. You are just describing. Now, here 1 to 5, continuously it has dropped. There should be some reason, right? Why the share or the Infosys share value has dropped from January 1st to January 5th. There is some reason. And suddenly it has picked up from 5th to, again, it has slowly risen like this. Again, there should be some reason. Why these 5 days it has fallen, and again why from 5th to 11th, how it has increased. There should be some reasons for both of them. The reasons is called as diagnostic analytics. Now on 11th, this is the share value. Now on 12th, what is the expected share value? Whether it is from here, the Infosys share price is going to increase or Infosys share price is going to decrease. That you are going to predict. So I'm going to predict the Infosys share price is going to increase. Okay, I'm predicting. Now, how you are predicting on this one? There should be some reason. That reason, you, for example, as a data scientist, I'm predicting this one. So, for example, I'm working in the Infosys company only as an analyst role or a senior data scientist. Now, I'm going to explain that team that by doing this one or this one, our value is going to increase by doing something. What you have to do in order to increase the share price, what we have to do? Some reasons will be there, right? That is called as prescriptive. The reasons behind the increase is prescriptive. The reason behind whatever was completed is called as diagnostic. Is clear? So here we are going to do these 4 types of analytics. One is called as descriptive, diagnostic, predictive, and prescriptive. These are the 4 different types of analytics. For doing all these 4 types of analytics, we have to get the data first. So the data will be in the database. From the database, you have to extract the data. As a data scientist, this is your first work. Your data scientist or data analyst, your first work is you have to extract the data from the database. Okay, what are the database? If, for example, you work in the market, how many types of databases are there? Miss, almost 70 to 80 databases are there. 70 to 80. Are we going to learn all these 70 to 80? Miss, not only you, none of them will learn like that. Okay, then, for example, let us take like this. This is a structured database. Okay, this is a structured database where it is stored in the structured data, that is in the tabular format. We are having MySQL, is called as database name. SQL Server, is also called as database name. Oracle is also called as database name. So like this, we are having three different databases, assume example. Now, for these three databases, how to extract the data from the database means we require only language called as SQL. For anything, SQL is common. The small syntax is different. Minute changes are there. Changes are there, but minute changes. Okay, that SQL. For example, if you learn the SQL and you have learned the SQL as per the MySQL, assume. After once you have shortlisted and your interview was completed and you have joined in the company, and in that company they are using SQL Server. Now what you have to do? You have to learn the automatically this SQL Server. Whatever the company you have joined, in that company, whatever the database is there, that database you have to learn on your own. How you can learn that one? Already you are familiar with SQL. So learning already SQL with MySQL, now if you have to learn SQL Server means how much time it will take for you to learn SQL Server, you know? Just 1 hour. That too in YouTube, any one video if you see also, you'll understand. Okay, just 1 hour it will take. To learn Oracle also, it will take for you 1 hour. Okay, in the worst case, okay, let us take, sir, from your perspective, 1 hour, sir. Okay, let us take from student perspective, 1 day. 1 day, right? From my perspective, if you think in that way also, it is maximum for you 1 day only. It can't be more than that. Because almost everything will be the same. Only small changes are there. That changes also you'll understand easily. What example this one? So for example, you are having one more database like that. Market 70 to 80 databases are there. So we have to learn. Now, the person who is going to shortlist you, one person is going to shortlist you. Your resume, one person is going to shortlist. One person is going to interview. These both people knows that you already completed MySQL and you have to work in the future on SQL Server. These both people know, without knowing only they have shortlisted. They know, right? They know that you are going to work on the SQL Server. They know your resume consists of MySQL Word also. They know. Both of them they know. In the interview, they'll ask you on which database you have worked means you are going to say MySQL. They know that one, but still they are going to hire you. Why? Because they also know that because MySQL, if one of them is very strong at MySQL means for them learning of SQL Server is just of 1 hour. It is not more than that. So based on that only they are going to select. You don't need to worry. No, sir, I want to learn all of them. And are you going to explain the differences and that minute changes? Will you explain means if I start explaining like that, I have to explain all the 15 to 16 databases related to SQL. If I start explaining, you will get confused by first one. You are going to learn first one only first time. If I start explaining simultaneously multiple things at a time, automatically it will lead to the confusion. Forget about the understanding of remaining things. First, you will not understand even the first one only. So whenever we are learning a new thing, when we are learning should not get confused. Learning should get the clarity. The more the clarity we get, the more easily we can learn. In the learning stage, never we should get confused. We should not get hurry-burry mode that this everything has to be completed in 1 day only, 2 days only. We should not do in that way. Then everything leads to the confusion. For example, till now, whatever the Python we have completed, if you try to cover that entire Python till now you have not prepared, but you want to prepare in 1 day means what happens? It leads to the confusion. If you want, you can try, right? So if you are practicing every day, the more clarity will be there. If you are practiced in 1 day, trying to do everything in 1 day means confusion will be there, right? Now, similarly here also, as a data scientist or a data analyst from a database, from a given database, whatever the database is there, from the given database, you have to extract the data. Okay, this is your first step, extract the data. Once you have got the data, immediately first you have to do, whether you are a data analyst or a data scientist, anything, first you have to do the descriptive analytics. Common, everyone has to do the same. Okay, descriptive analytics. And along with the descriptive analytics, if you are working only on the diagnostic analytics, if you stop here and whatever the graphs are there for doing the descriptive analytics, for example, I have done the descriptive analytics, some kind of, sir, in this class, 70 girls are there, 30 boys are there. And out of this 70 boys, out of 70 boys, 40 boys are from IT background and 30 boys are non-IT background. And these many boys are from MTech and BTech and BSc like this. If I explain like this with my theoretically, everyone others will get sleep, right? The others to whom you want to explain, for them, easy way we have to explain means we have to show them as a graphs. We have to plot them. So whenever you want to explain the descriptive statistics or diagnostic analytics, you have to plot them. You can't tell as a theoretical way. You have to plot them. The descriptive analytics you have to plot. Diagnostic analytics you can't plot. That is the reason. So reasons we can't plot, right? So descriptive analytics we have to plot. All the descriptive analytics, whatever the descriptive analytics is there, the entire descriptive analytics we have to use the plotting. Analytics plus plot. Up to here, if you stop means, then you are called as a data analyst. The data analyst using any Power BI tool or using anything or Tableau or anything in a company, they will just work up to here on. They'll take a data, and from that data, they will understand, they will do the descriptive analytics and apply various types of plots. Multiple plots are there. For different types of variables, different types of plots are there. So all the different types of plots they'll keep, and everything they'll presentation they'll do at the end. That is the role of the data analyst. Now, based on that, whatever the data, based on that, we have to predict. We have to do the prediction. That is third step. We have to do the prediction. That prediction will be done by the data scientist by applying the machine learning and artificial intelligence. Simply to say, this is called as statistics. This is called as ML and AI. Combining these two is called as data science. Right? In a simple words. Is that clear, guys? So let us focus on the descriptive statistics part first. Descriptive statistics is also called as descriptive analytics. Okay. So now I have told you that we are having two types of analytics. Sorry, two types of statistics. SQL is called as language name. MySQL is called as database name. Both are not same. MySQL is called as database name. Okay. Shubham. MySQL, SQL Server, Oracle, all these are the database names. They are the names of databases. To extract the data from all these databases, we have to use some language. That language is SQL language. Right? Now, let us keep that one side. Statistics comes to the statistics. What is meant by statistics? Measure and analyzing the data. Here we are having two types of statistics. One is called as descriptive statistics. Second one is called as inferential statistics. Right? Descriptive statistics means describing the data. Sir, already describing the data, you told descriptive analytics now. Both are same. Describing the data. Okay. Then what is the difference between stats and word of analytics? Describing the data values and you are analyzing manually, then it is called as statistics. If you are representing that one in the plots, it is analytics. If you change that one into plots, means analytics. Example, let us take an like this. Okay, where gender column M, F, M, 3, 6, 9, 10. Okay, total 10 points are there. Okay, this is the column. If you write df of gender dot value counts, if you are using the dot value counts, then you are having with respect to unique categories are M and F. How many M's are there? 1, 2, 3, 4, 5, 6, 7. 7 of them are there. F's, 3 of them are there. This is called as descriptive statistics, which is nothing but count. Describing the data. You are just describing the data. The same thing you are representing using the bar plot 7 and 3. Then this is called as analytics. You are analyzing the data from this. More number of boys are there in this class. That's it. And as if you analyze miss analytics, if you don't analyze miss statistics. Just if you keep the value miss statistics, right? Now here whatever we are having. So the representations we are going to do for different types of data in a different way. Okay. So for the discrete data, we are going to represent in a different way. Or like continuous variables, we are going to represent in a different way. Time series data, we are going to represent in a different way. Different types of data, we are going to represent in a different ways. Right. So statistics, we are having of two types. One is called as descriptive, one is called as inferential. Out of which descriptive statistics means collecting, presenting and describing the data is called as descriptive statistics. Inferential statistics means estimating the population based on the sample data is called as inferential statistics. Okay, is that clear? Now data, different types of data. Already we have seen what are the different types of data, that is continuous data and discrete data. Continuous and discrete. Second one is called as discrete. Within the discrete, we are also having the discrete count, and discrete categorical. Out of discrete categorical, again, we have divided into nominal and ordinal. Right? This is one flow chart. Flow chart number 1. We are having another type of flow chart. Okay. Whereas this one is also numeric. This is numeric. This is in the text. Two of them will be in the numerical format, and this is in the text. Now I can represent the same flow chart in a different way. Same type of flow chart in a different way. That is entire data into two parts. One is called as numerical data. One is called as text data. One is numerical data. One is text data. Numerical can be again subdivided into two parts. One is called as continuous, and one is called as count. Whereas text data, whatever the text data I'm having, it is with respect to nominal and ordinal. I can represent in this way also. This numerical data is also called as quantitative data. Quantitative. Quantitative means nothing but quantity. It is going to represent the quantity. Quantity means numbers. Quantity, how much quantity you want. That is with respect to weight or with respect to the number. So the quantity represents with respect to the number, right? This is also called as quantitative data. Whereas text is also called as qualitative. Quality, it tells about the quality. Quality you are going to say as good or bad, average, everything like this. The quality you are going to say in the text. So it is also called as qualitative data. This is called as quantitative. This is called as qualitative. Okay. So quality will if I ask you the quality, how is the quality means what do you say generally? Good. It is a good quality, nice sir, or something like this, right? The whatever you are using, the text is also considered under qualitative. Simple. Quantity. If I ask the quantity, how much quantity you want? Something like this. So quantity comes under numerical. So data is either quantitative data or qualitative data. Quantitative is also called as numerical data. Quantitative is also called as text. In the numerical, we are having continuous and count. One is having with the decimal, one is not having the decimal. Count never has the decimal. If you ask count example, like a number of cell phones, number of mobiles, number of cars, number of gays, everything number. Just it is a count. How many books you are having? Count. Right? How many pens you are having? Count. How many beatings from your wife? Count. Okay. Everything is count only. Just right. So number of laptops, count. Everything is count only. So count never has with respect to a decimal value. Never it is possible. Never it is possible. Just it is. We are just counting that one. What is the count we are doing? How many are there? They are count. We are just counting. Then we are counting means it comes under count. Otherwise, it comes under continuous. Simple. Right? Now, the same thing I have represented in the PPT also, and I'm going to upload this PPT. Right? Everything I will upload in the drive. So this PPT also I'm going to upload in the drive. The only thing is you can't download. The course you can download, but PPTs you can't download. You have to use internet, and you have to open every time the Google Drive only. Then only you can access. If I do give the download option, then I don't need to give for lifetime access of Google Drive. Since I'm not giving the download option, even after 2 years or after 3 years, if you want to revise also, the notes will be as it is. Lifetime. It will be in the lifetime. Right? Now, the quantitative, whatever the quantitative is there, the quantitative data is measured in terms of numbers. Second one is qualitative data. Quantity like a height, weight, score, your marks, all this comes under with respect to quantitative, because they are in the numbers. Which are in the numbers, they all comes under quantitative. Which are in the text, they comes under categorical data, or which is also called as quantitative data. Right? Now within the quantitative data, discrete, continuous. Discrete count is there, continuous variables are there. Discrete count means it just represent in terms of numbers where we are not having any kind of decimal value. No decimal value is possible. Okay, no decimal value is possible. Next, whereas coming to this continuous with the decimal, whichever is having the with decimal, that values comes under continuous. Next, ordinal and nominal. Nominal means where there is no order, natural order. Order you created means that is from your perspective. Your order is not the universal order, right? There should be universal order. Everyone should have the same order. That type of order only is considered as the ordinal. Yours order is as per your choice. For example, India, America, Russia. Which one is the best country? If you are patriotic means you'll say India. If you are money perspective commercial means you'll say America. Right? So America, India, Russia, which one is means there is no order. They are just names. If you are considering as per the GDP wise means America is the first position. If you are considering population wise, India is in the first position. If you consider area wise, Russia is in the first position. From question to question, from perspective to perspective, the order is changing. Then it is called as nominal. In this class, Suresh, Mahesh, something students are there like this. Then who is great miss? Everything are name only. Okay. So for example, we are having Mahesh Babu and Pawan Gayan. Mahesh Babu is greater than Pawan Gayan or Pawan Gayan is greater than Mahesh Babu? No, nothing. Just names from their names perspective. If you are taking fans perspective, that is different. Right? But if you are considering from the name perspective, names of the every person is same. Just their names only. Okay. So there is no order between them. They are called as nominal. Just their names. Similarly, ordinal data means where we are having with respect to some order is there. For example, if letter grades are there. Okay. Grade is there. If only letters are there, then it is called as nominal. Grade word is there, right? This grade word, grade makes with respect to the difference. So then when compared to F, C is better. When compared to C, C plus, B plus, A and A plus. Right? This is universal for everyone. Not only for you, for me. When compared to small, medium is more size. When compared to medium, large is more size. Right? Simple. That is ordinal data. Right? Is that clear? Ordinal and nominal. For categorical data or with respect to quantitative data, I mean, categorical data is also called as qualitative data. For qualitative data, we are going to represent a different plots. Qualitative data, we are going to represent a different plots. For quantitative data, we have to represent a different plots. Let us start with the qualitative. For qualitative, that is nothing but categorical data. How we are going to represent is either bar plot or second one is called as pie plot. Already we have done both of them in the pandas, already completed also. So what is meant by bar plot means just representation. Whatever the entire data is there, the entire data you are representing on a plot. Okay, where on the y-axis you are considering the frequency. On y-axis, if you are considering the frequency, or which is also called as count or frequency, both are same. On y-axis, if you are considering the count, and on x-axis you are taking the each category on the x-axis, then it is called as bar plot. The same thing you are representing using a circle, and in this way, then it is called as pie plot. Right? So just for whenever there is a discrete variable, whether it is a ordinal data or whether it is a nominal data, just you have to represent in the bar plot or pie plot. For example, we are working on a something like this country names. Okay, India, Russia, US, India, US, India, US, India, India, India. Something you are having like this. 3, 6, 10. 10 are there. Now the same thing, just you have to represent. This is the data. This is the data they have given to you. This data you have to represent. Representation of data. Okay. Now we are going to represent this data by using a bar plot. On whenever you are considering the bar plot, here you have to take each category, that is India, US, and Russia. By default, it will take in terms of alphabetical order. So first India will come, Russia, and US. By default, alphabetical order. Now here just each category, whatever the category you are having, each category. Now each category, for example, India, how many Indias are there? 1, 2, 3, 4, 5, 6. So up to a height of 6. On the y-axis, you have to take a count of 6. 1, 2, 3, 4, 5, 6. This is the height. So this height of 6, you are going to represent. Wherever the 6 is there, that height of 6 means on the y-axis, you are going to take the count or frequency. Height of 6. Russia, 1. Only 1. 1. And yes, 1, 2, 3. 3 of them are there. Okay. So this is the representation of the data. This is also called as frequency distribution. This is also called as frequency distribution. What is meant by distribution? Means the entire data you are distributing here. Here total 10 records are there. 6 plus 1 plus 3, 10 records. This entire data you are distributing. How you are distributing? Based on their frequencies you are distributing. So it is called as frequency distribution. Which variable you are representing? Country name, which is nothing but discrete. So this is also called as discrete frequency distribution. If you are representing continuous variable, means continuous frequency distribution. Discrete variable representing, so it is called as discrete frequency distribution. Is that clear? Is that clear? Discrete frequency distribution. Distribution means entire data. Simply write in simple words, entire data. Entire data representation is called as distribution. Entire data representation is called as distribution. Whatever the data is, the entire data you have to consider. In that, no sir, I'm not interested with Russia. Russia is anti for us. You can't select like that. You have to take entire data distribution, entire data representation you have to do. Frequency, what is meant by frequency? Count. The distribution, how you have to represent means through count. Representation you have to do based on count. Which variable? Discrete variable. Discrete count representation. Discrete variable count representation is called as discrete variable count representation is called as discrete frequency distribution. The count you have to represent. Count only is called as frequency. So, for example, on the axis, instead of frequency, if I take the probability, then it is called as discrete probability distribution. On the y-axis, I am taking the percentage, discrete percentage distribution. If you are taking on y-axis some other thing, whatever the thing, that is center. First word, last word remains same. In between, if on y-axis you are representing probability, assume probability you are representing, then it is called as discrete probability distribution that we are going to see in the further. Okay. Or otherwise, let us complete now only. Okay. So this is called as discrete frequency distribution. Similarly, the same thing you are representing using the pie chart. One is bar chart, one is pie chart. Right? Is that clear, guys? So for discrete variables, we are going to work on the bar plot and pie plots. For various continuous variable, both of them are not applicable. Either this one or this one, both of them are not applicable. Right? Only for discrete variable, these things we can apply. Now, let us move on to the understanding purpose, easy way. Immediately, if you understand now itself, that is best. That is nothing but probability. Probability. Now, what is meant by probability? Probability means whatever you are interested, count of whatever you are interested, divide by total available. As everyone will explain with a simple example based on the coin example, heads and tails. I'm also starting with a simple example and I will increase the example level. Right? First, let us start with heads and tails. There is a coin where the coin has with respect to one head and one tail. Now, what is the probability of head? Means total how many are there? Means 2 are there. 2 options are there. Total options are 2. Out of which I am interested is this one. Only head I am interested. How many hedges are there? Only 1 are there. 1 by 2. How many tails are there in the given data? 2 out of 1. For example, this example is completed. Example number 2. I. Don't ask what is I. Example, letters. This time letters, not head, not tail. Letters only, just their letters. J, H, K, H, J, H, I. T. Something I'm having like this. Okay, some letters are there. Out of which, what is the probability of T? How many T's are there? Because count. Probability means count what you are interested. What you are interested is T you are interested. Out of total available. First total available are how many I have written? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I will increase one more. J. 13 is not a good number. Okay, let us go with 14. Okay, out of 14, how many T's are there? 1, 2, 3. 3 only. So 3 by 14. That is the probability of T. That's it. Write the total, whatever available are there on the denominator. On the numerator, what you are interested, just count them. How many are there? That's it. Completed. That is the probability. Right? Probability of H. Total is 14. Out of which H is 1, 2, 3, 4, 5. 5 by 14. Probability of S. How many are there? 0. 0 by 14. Not them is 0. That's it. Is there miss count? Not them is 0. Simple. Right? Probability of I. HT completed. I. 1. 2. Probability of I is 2. 2 by 14. Next, probability of J. 1, 2, 3. 3 of them are there. Right? So, 3, this is called as probability. This is for discrete variable, not for continuous variable. I'm explaining only for discrete variable. Discrete variable probability, right? So this is the probability. So probability of T is 3 by 14, probability of H is 5 by 14, probability of I is 2 by 14, probability of J is 3 by 14. If you add the entire probability, what is the other letter? K. Probability of K is 1 by 14. Right? So if you observe this one, the probability, what is the minimum value of the probability means 0. If that is not available, what is the probability of Mahesh Babu in this class means 0. Right? If it is not available means 0, right? Simple 0. Just you are asking a discrete variable. Name is a discrete variable. Probability of a discrete variable is how many are there divided by total. Simple. For discrete variable, just count divide by total. Right? Now, for this probability, whatever the probability we are having, this example, in this, if you are having example like this, H, 4 H's are there. What is the probability of H means 4 by 4. This is the maximum. Can you get other than 4? Can you get more than 4 on the numerator? Is that possible? Because this is the total. Total only the maximum. Out of total, how many are there? Only is the numerator. Numerator is always less than the denominator. It can't be more than the numerator. So means the probability is always less than 1. It can't be more than 1. Never it is possible because numerator cannot be more than denominator. Reason behind that is, so probability is always less than 1. Never it can cross the more than 1. Right? So the probability, the maximum value of the probability is with respect to 1. The probability can be equal to 1. If all of them are same, the maximum probability is 1. If that is not available, the minimum value is 0. Can the probability can be negative? Negative? No, because count. If there is, then there means 0. If not, there means 0 only. Negative we can't get, right? In the count, negative values are not there. Count means minimum this much to maximum infinite. Just you are counting them. So count cannot be a negative value. So never the count can be negative value means, then how the probability can be negative? Now simply now what is the probability range means 0 to 1. Whether 0 is included or not means included. So square bracket. 1 is included or not included. So square bracket. Square bracket indicates they are included. Whenever there is an infinite word, you have to use the parenthesis. You cannot use the square bracket. That parenthesis says that it is not included. Now, for example, if I am writing like this, 0, 1. If I write like this, what is the meaning of this one means 0 and 1 both are not included. That is the representation. What is the what is the meaning of this one means 0 is included, 1 is not included. That is the meaning. In the max, the representation will be in this way. Right? So in the notes you can write the probability cannot be negative. Probability can't be negative. Reason behind that, why it can't be negative? Because count can't be negative. The numerator should be negative, right? If order to get the probability negative, first numerator should be negative. Numerator only not negative. Denominator is not negative, neither numerator is negative. So then from where we can get the negative value? So probability cannot be negative. Second, probability can't be more than 1 because the count cannot be more than the total. Right? If everything of same miss, then the probability can be 1. If nothing is available miss, the probability of, in this case, the probability of T is 0. In the given example, in my given example, H, 4 H's are there, but T is not there, 0. The probability can be, the range of the probability is from 0 to 1, where 0 and 1 are both are included. Right? Next, now if you observe this one, whatever the categories are there in the given data, for example, let us take this is the data. In this data, what are the categories? Complete data. This is the 14 values. This is the entire data. Out of this entire data, tell me what are the unique values? T, H, I, J, K. These are the unique values. If you calculate the probability of T, probability of H, probability of I, probability of J, and probability of K, the total is going to be 1. The sum of the probability is equal to 1. Because all of them are having the denominator of the same total. Out of total, how much part of the thing is T? That percentage only. Out of 100%, how much percentage is T? How much percentage is H? How much percentage is I? How much percentage of J values are there? How much percentage of K values are there? Percentage can cross more than 100. Similarly, everything are less than 14 only. So that is nothing but T. What is the probability of T? We have written 3 by 14. Okay, 3 by 14. Next, H, 5 by 14. I, 2 by 14. J, 3 by 14. K, 1 by 14. 3 plus 5 plus 2 plus 3 plus 1 divided by 14, which is nothing but 14 by 14, which is equal to 1. Always the probability is equal to 1. Always the sum of the probability is equal to 1 for any data set. Whatever the worst data set also, always the sum of the probabilities is equal to 1. Is that clear? Now, let us take this example, one new example. Let us consider a new example. Choice is yours. You can select as per your choice of data. Take anything as per your choice of the data. You can take name, you can take count, you can take anything as per your choice. Whatever you want, you tell me. I'll write it. Guys, tell me anything. Example, as per your choice. Huh? Day of a week. That is Monday, Tuesday, Wednesday, Monday, Tuesday, Wednesday, Monday, Tuesday, Wednesday, Monday. I'm ignoring remaining 4 days. Just I'm taking only these 3. Monday, Tuesday, Wednesdays only. Okay, example. Now, this is the date. Total 10 are there. Now, how many unique values are there? First one, unique values. Monday, Tuesday, Wednesday. Okay, so now just you take on the x-axis Monday, Tuesday, Wednesday. Just I'm representing them. Monday, how many Mondays are there? 4 of them are there. Just write 4 of them. Count. Tuesday, 3. Wednesdays, 3. Okay, this is called as discrete variable. So day is discrete. This data, whatever the data is the frequency. So I'm representing the frequency. So this is called as discrete frequency distribution. Okay, completed. Part 1 is completed. Part 2. What are the unique categories are there? For each category, I'm calculating the probability of Monday. What is the probability of Monday? Probability of Tuesday? Probability of Wednesday? Represent the same thing. Monday, once again, Monday, Tuesday, Wednesday. But this time on the axis, not count, probability. 4 by 10, which is nothing but 0.4. So I'm going to take 0.1, 0.2, 0.3, 0.4. Earlier I have taken is 1, 2, 3, 4. Earlier is 1, 2, 3, 4 numbers on axis. This time 0.1, 0.2, 0.3, 0.3, 0.4. Probabilities I'm considering on the axis. I'm representing the same height, which is of 4, which is of 3, and which is of 0.3. What is this is called as? Discrete. On the axis, what you have represented? Probability. So this is called as discrete probability distribution. This is called as discrete frequency distribution. This is called as discrete probability distribution for this data set. Is that clear? Probability and discrete probability distribution. Any questions? The sum of the probabilities in this case also. The probability of M plus probability of T plus probability of W, which is equal to, again, 1. And the probabilities always be less than 1. It can't be more than 1. In this case, every time that is fixed. Okay. Is that clear, guys? Any questions of discrete variable, discrete probability distribution, and discrete frequency distribution? It is clear, means next we'll move on to the continuous. Discrete is the easiest one when compared to continuous one. But of course, continuous also easy only. Comparatively. Comparatively, it is a dead easy. Done, guys? For this data set, I have taken the frequency distribution and probability distributions. Probability is also called as percentage for discrete variable. Discrete variable probability or percentage, both are same. There will be no difference. Percentage also same only. 4 by 10 only. Percentage also 40% of the values are M, 30% of the values are T, 30% of the values are W. For discrete variable, there is no difference between the percentage and probability. Both are same as it is. If you want to represent on y-axis percentages, take the percentage and write same answer. Then it is called as discrete percentage distribution. Right? Clear, guys? Any questions till now? What is the difference between them then? One is count and one is probability. Here you are representing count, you are representing the probability. right? Next question. So please repeat the discrete probability example. See, discrete probability means the discrete variable. What are the discrete variables you are having? This is the discrete variable data. This column, whatever the column is a discrete variable. In this discrete variable, just I am representing. Now let us take the yesterday's example data set, liver patient data set, whatever I have shared you in the previous class. Okay. In this, we are having with respect to liver patients S and Os. This is a discrete variable. This is also a discrete variable. Two discrete variables are there. Now for this, what are the unique categories we are having? F and M. How many Fs are there? Three. Three of them are there. How many males are there? 7. Then if you represent the same thing, that is F with respect to 3 and males with respect to 7, then this is called as discrete frequency distribution. The same thing you're representing in terms of you're calculating the probability. What is the probability of F? What is the probability of F means 3 out of total is 10. Here 3 Fs are there. Your interested thing is F. Count of your interested one. Your interested one is F. Your interested one. Out of how many are there miss with respect to count? 3 of them are there. 3 out of 10. M. Your interested one now is M with respect to males. How many are there? 7. 7 out of 10, which is 0.7. This is 0.3. Now represent the same thing. M and F on the x-axis once again, but this time P of M. You have to represent P of M, not count of M. P of M and P of F. If you are representing the probabilities, then it is called as discrete probability distribution. Is that clear? Now, next. In the discrete variables, within the discrete variables completed. Now let us move on to the next one called as continuous variables. So the continuous variables will continue tomorrow. Right? The continuous variable will continue tomorrow along with the continuous probability distribution along with the continuous frequency distribution. The continuous frequency distribution is also called as histograms, which is one of the most important, and will continue tomorrow.